So the other method that you know for solving systems of linear equations is substitution. So that's the next one that we're going to be talking about. And I want to look at a really difficult problem, one of the more difficult ones from the text. So this problem goes like this. So our first equation that we have, our first plane, is 6x plus y minus 4z is equal to negative 8. Then y over 4 minus z over 6 is equal to 0. And then 2x minus z is equal to negative 2. Okay. So we have our system here, and we can begin solving this using substitution with this third equation here. The third equation, it already naturally seems right to solve for z. So I'm going to bring that negative z to the other side and bring the negative 2 back over, and I'll be left with z is equal to 2x plus 2. Okay, then I want to take this term right here. So I just solved for z in terms of one variable, x. So I want to take that and plug it into the other equation that has one other variable in it, y. So if I do that, then I'll have an equation in terms of y and x. And the end goal would be to have two equations, one z in terms of x and the other y in terms of x, so we can plug all of that back into the first equation and solve for x. So if I plug this in for z here, I'll be left with y over 4 minus, and then 2x plus 2 is the numerator, over 6 is equal to 0. So that's the substitution part of it. So if I bring this term to the other side, I'm left with y over 4 is equal to 2x plus 2 over 6 can be separated into x over 3 plus 1/3. And then if I multiply everything by 4, I'm left with y equals 4/3 x plus 4/3. Alright, so now I have y in terms of x, and I have z in terms of x. So we can take both of these and substitute them into the first equation, and we'll have all variables in terms of just x. So if I do that, I'm left with, I'm going to change colors. I'm left with 6x plus 4/3 x plus 4/3 minus 4 times the quantity of 2x plus 2 equals negative 8. All right, so now we have this really long expression or equation that we can start solving for x, combining like terms. So the 6x and the 4/3 x, that combines to make 7 and 1/3 x. And then the negative 4 needs to be distributed to both of the terms inside the parentheses. So that negative 4 times the 2x will leave me with a negative 8x. And that negative 8x and the 7 and 1/3 x will combine to make negative 2/3 x. So negative 2/3 x. And then we have the negative 4 times the positive 2. So we have negative 8 there. And then combined with the 4/3 leaves us with negative 6 and 2/3. And then equals negative 8. Okay. So now all we're left to do is to bring the 6 and 2/3 to the other side and then solve for x. So we'll be left with negative 2/3 x is equal to, so negative 8 combined with 6 and 2/3, that leaves me with 1 and 1/3, or negative 1 and 1/3. which is actually negative 4/3. And then if I multiply out this negative 2/3, I can multiply everything times negative 3/2 to cancel the negative 2/3. And then I'm just left with x equals, and then the 3 and the 3 cancel, the negatives cancel, 2. And there we go. We have in our expression, we have a value for x now, which is 2, which we can now plug back in to solve for z and y. So z, we found out earlier, z is equal to 2x plus 2. So if I wanted to plug that in now, I could say z is equal to 2 times 2 plus 2, because we've solved for x now. So z is equal to 4 plus 2, or 6. And now we have z. And then the last one that we can plug in here is for y. We could plug in 2 into x here and see what we get. We'll be left with, and change colors one more time. We'll be left with y is equal to 4/3 times 2 plus 4/3. And that leaves us with 8/3 plus 4/3, which is 12/3. Or in other words, y is equal to 4. All right, so we can write our ordered triple here as x comma y comma z, or 2 comma 4 comma 6.